out of the class to explain how to buy a car, like how not to get ripped off by car dealers. Went over a formula about our interest rates or something. That was pretty cool. Like you go to a car shop, they try to tell you this, and they try to add you money. Whenever really the whole formula just give us help. He knows we're broke.
Gotcha. I understand. Which means
I don't remember the formula. I wrote it down somewhere. You know who the villain is in the sequel? I'm trying to find out.
Man, your stream of consciousness is hard for me to keep up with.
That's why I'm running up to begin with, because I was going to ask you who the villain was. I saw a picture, but I never found out.
I forget. I heard something, but I forget.
What classes are you teaching next semester?
Same. So normally full-timers pick the fall spring schedule. Every now and then we'll change the spring class.
So you do 176 and stats?
Stats 176 and 88. Yeah. I like variety. Okay. So the next step here is matrices, and I think a lot of people have seen them before. A lot of people have worked with them. But a matrix.
Is this 10
Yeah. Remember synthetic division? You guys, how do you feel about synthetic division now? Good. Doesn't it kick ass? And the main good thing about synthetic division is it gets out of the way the stuff that's not important. What's important in division is the numbers that are resultant from the work. Who cares about the x squared and the x cubed and the x and all that kind of crap? Just get it out of the way. So what a matrix, one thing it does, and this is not the only thing it does, trust me, there's an entire class, linear algebra, about applications of matrices. But one of the most fundamental things it does is it gives us a way to rewrite a system of equations to make it easier to work with. So for example, if I had, what was that one we just did? Oh no, what's the one we did earlier? That was 516. Does somebody have that in their notes?
I have it in my calculator.
5x minus 7y equals 11?
No, there was the one with 3 variables.
X minus 4y plus z equals 7. 2x plus y minus z equals 5. Negative x plus 3y minus 2z equals negative 14.
Thank you. So the way this would look like in a matrix, all a matrix really does is it organizes this into columns and rows. So each row, in this case, the first row will be the x row. So it's understood to be the x row. I don't need to write all the freaking x's over and over again. The next row is the y row, the next row is 0, and the last row is the answer row, the whole number row. And as I move, it's just going to be the coefficients that show up. So it's a lot like, it feels a little bit like synthetic division, like I said. Oh, Jeff. And I normally do one little thing that the book doesn't do. I put a little line there. So this is what's called an augmented matrix. It's a matrix with its equal to number part thrown in there also. Because you can work with that matrix by itself. That's kind of like the equation matrix. This is called the augmented.
If one of the variable is not there, equals 0 or 1?
Yeah, exactly. If I had 2x minus z, it would have been 2, 0, negative 1. Just the same thing we do in synthetic.
Would it be negative 14?
Negative 14, yes. So that's an example of where things really suck. When you forget a negative sign, and I just showed you how easy it is to do that. One negative sign throws a whole damn thing off, and you start getting these weird-ass answers, right? So that's where it gets a little bothersome. So what we're going to do first is figure out what is the work going to look like in a matrix now compared to what we had to do by hand. The biggest problem with doing this by hand for students is bookkeeping. Bookkeeping. That's why I have them equation number 4, equation number 5, so they don't forget what the hell they got, where it came from. What the matrix really does for me, one thing it does is it makes it easier to keep track of what I've got currently being used. So what was the first thing we did here? I think we did 1 plus 3, right?
Yeah.
When we did 1 plus 3, we got those canceled. We got negative y minus z is negative 7, right? Now, tell me this. Which equation would you say is better? Equation 3 or equation 4? 4 is better because it's got less unknowns in it, right? It's one step closer to being something I can solve. So what the matrix does is it keeps track of all the equations I currently consider to be the best. So the way I would do this is I would say, actually, what an equivalent to doing equation 1 plus equation 3 is doing row 1 plus row 3. So trust me on this. You want to tell yourself what the hell you're doing, because when you go back to look at a problem, if you haven't written what you're doing, you don't know where the hell the stuff came from. And when I go to grade it, I have the same problem, and that's not good. The thing you got to get used to with a matrix is you're always overriding old information with new. So those of you that use computers, this should be something very familiar. We just said that equation 4 would be better than equation 3. So why keep equation 3 around? It's still valid, but I don't need it in my list of best equations. So what I would do is I would do row 1 plus row 3 and put the results in row 3. So what this would look like is, this is still here. This is still here. But when you add row 1, now look how much easier it is to look at. Row 1 to row 3, 0, negative 1, negative 1, negative 7. And what does this last thing mean? It means no x's, minus y, minus z equals negative 7. That's exactly the equation we got there. So far, so good? So I kind of doing this in a different order than I normally do for matrices. I want to do this first, show you how this kind of works. I can move rows around because do these really have to be in this order? So then the rows don't have to be in any order. But could I really, do I want to start doing this, moving columns around? Not really, because this is the x column, the y column. I don't want to lose track of that. Okay, good. So what is my end goal here then? When do I know I'm done with the matrix, really? There's two different levels of being done.
0, 1.
Yeah. So one level, my goal is one of two goals here. One goal would be to get this. 1, number, number, number. 0, 1, number, number. 0, 0, 1, number. Because then I know, what does this last row mean? What if this was 1, 2? What would that say? Z equals 2. And then I can throw this into y plus some z equals some number. I can throw that in and figure out what y is. And then I can throw those two in to figure out what x is. How we doing so far? Okay. This is what's called Gaussian elimination. And this is actually what's called upper triangle, yeah. Yeah, row echelon form. Now, the way that I like better, personally, the way that just kind of makes a little more sense, is to go all the way. Why stop here? So, do you understand now what this kind of points to as far as process goes? We just used this one to kill that to make it a 0. My next goal, my next like mini goal should be to get a 0 here. And then I want to try to get a 0 there. And once I'm there, I can actually solve it by translating it back into equations and solving it there. Is that cool? We'll do that here. But if I go further, just go to here. I can just get there, then I can just read the answer off directly. I don't have to translate anything back into equations. I can just see x is this, y is this, z is that. Done. And it's relatively easy to make zeros happen. The whole thing here is I want to make zeros happen. I want to try to make a 1 if I can, because that's the easiest way to make zeros happen, because 1 can become anything I want it to. And then I just add multiples of it to make zeros happen. Then I move to the next column, do it again. Move to the next column, do it again. So what would be the next step here then? Do it one more time, sorry. Yeah, row 1 and 2, I want to take twice row 1 minus row 2 or something like that, right? So I could do 2 row 1 minus row 2, put the answer where? Where do you think I want to put the answer? Where do I want that 0 to show up? Yeah, row 2. Keeping this goal in mind. Maybe. This is brand new to you. Give it a chance. So which row is going to stay the same? In fact, really, until you get more comfortable with this, you just want to change one row at a time. So the only row that's going to change in this is row 2. It's going to get overwritten by this result. So row 1 is the same. And row 3 is the same. Now let me show you what I do. And personally, I kind of do this in my head. But even, I don't care how good you are, that still opens yourself up to mistakes. And one little thing I'm going to actually do here is, let's do this instead. -2 row 1 plus row 2. And the only reason I'm going to do that, it's still going to give me the right thing that I want, right? But then I can leave row 2 alone, truly, in the process. So what I mean by that is the only thing I then have to change is here I'm going to put what this would be if it was -2 times this. You guys with me?
Can you repeat it again?
Yeah. So this in purple is -2 times row 1. Which if you look back at the work we did by hand here, that was the next thing we did. We did -2 times this plus this. If you look back at the work we did by hand. There is no reason to write here -2, 8, -2, -14. Because I could then just divide it and bring it right back down. So it only needs to be this for a second while I add these together. All right? So what do I get as a result? -2 plus 2, 0. 8 plus 1, 9. -2, wait, yeah, good. -2 minus 1, -3. And then -14 plus 5, -9. That's what we did. That's out there.
When we do these problems on test or quiz, you look for R1 plus R3 to that. I mean, I know it's going to help us out.
If everything's fine, if I can see what you did, the problem with not putting this down is if something goes wrong, there's no way I can tell what you were trying to do. So then I can't give you partial credit as much. So I'm so far pretty good here, right? I got these 2 zeros. Now I want to move to the next column and try to make zeros in it. Now before I do that, I could kind of pretty this up a little bit, right? This is really...
This is like the Rubik's Cube, right?
If you're not
Trying to get all
careful,
the sides.
the nice thing, if you do this in a very systematic way, it sounds like you're worried about losing a zero.
No, but it kind of looks like you're trying to do it like the Rubik's Cube, trying to get zeros.
I'm with you. I understand. I was never any good with a Rubik's Cube, to be completely honest. I just couldn't really. I'll be one of those that would go, screw it, let me just rip these off.
Yeah.
I'm just too practical. Like, what's the end purpose? No, there, it's done. Yay. So a little intermediate step I could do right now is I could divide these 2 rows by something, right? I could divide this row by 3, right? Just to keep all these whole numbers. You can break fractions if you want to, but I don't want to. And I can divide this one by -1, right? Is that cool? A little cleanup step. So that will become 1, -4, 1, 7, 0, 3, -1, -3, 0, 1, 1, 7. Now the thing I'm being really lucky about here, and it truly is luck because I did not design this to do this, I do have a 1. If I didn't have a 1, there are ways to make a 1 without making fractions, right? You can imagine. If I had a 5 here and I wanted a 1, I have to divide by 5. I don't want to do that, right? So there are smart ways to make it happen. But I do have a 1 there. So what would I do next? Where do I want that 1 to be, by the way? Looking back at my goal. I want that 1 to be in the middle, don't I? So I could switch these 2 around and then start killing above and below it. Right? I could use that 1 to kill that. I could use that 1 to kill that. You guys kind of with me? The really nice thing, if you do this column by column, that 0 is not going to screw with that 1. You're not going to lose that 1. You with me? So you don't want to lose 1s, but even more important, you don't want to lose 0s. If you have to lose a 1, you let it go. But if you're about to lose a 0, don't. Zeros, you don't want to lose them because that's a variable that you killed. You don't want it to come back to life. So, several things I could do here. Let's do something a little more directly. How would I make that one kill that 4, that negative 4? Yeah, multiply by 4, so I can take 4, 4, 28.
Why we don't switch it first?
We could. I'm going to switch it here as I go. Is that right? So the middle, I'm going to put that in the middle. Okay, so that's going to stay the same. I'm going to put that on the bottom. And I'm going to put the result, row 1 plus 4, row 3 goes into where? Where am I going to put that result? Row 1. I love it, because that's where I want the 0 to show up. Okay, now if you've never seen this before, give yourself a chance. Again, like I said. Right? So I don't know if you guys kind of follow. I'm doing the exact same steps I would if I were using these, believe it or not. I'm eliminating variables. Every time I'm doing it between a pair of equations, right? Between a pair of rows, I'm killing a variable off. Making a 0 in this matrix is the same as killing that variable.
Why are you doing 0?
So that that variable's gone. Well, in fact, I'm going to this, really. If I can go to this, you certainly should be able to go here. So I'm going to go to this end result here. I'm going to go all the way here. If you can get here, you certainly, this is just stopping early. Right? Bless you. Thank you. Okay. So let me do this. Let me address your question by doing this. If I did want to stop here, I would want to kill that 3. Are you with me? Because then I could put it there, there'd be a 0. Would that make you feel better if I did it that way? Yeah. Okay. So let's do this. So instead of killing that negative 4 first, we'll kill that 3 first. Not a big deal. I had to do one and the other one. But let's go ahead and get to this place first, and then I'll keep going. So if I take row 3, what do I have to do to it to add to row 2? Yeah, negative 3 row 3 plus row 2, and put the answer where? And row 2, yeah. Okay. And then we can switch them. Is that right? We can put row 3, we can switch those two. It's not a big deal to switch those. So the first one's going to stay the same. He's like on the sidelines for right now. So now I want to multiply by negative 3. And add it. So negative 3 plus 3, 0. Negative 3 minus 1, negative 4. Negative 21 minus 3. And then this stays the same, 0, 1, 1, 7. So just to make it look the same, don't worry, I can switch those around. Oh.
Z is 6.
Yeah, good. Right, now in this row I can divide by negative 4. And I can see that Z would be 6. Cool. So that is this goal. If I can get here, I can then translate back into equation and solve. To me, that's sort of a little lame. That's not really using the matrix all the way out. Why wouldn't I just go ahead and solve the whole damn thing by hand then? Right? Why stop halfway through? Why not just keep using this matrix to go all the way through? But it's a good point, though. I like that you said. So this would be Z equals 6. What equation is this?
Y plus
Good. No x's, y plus z is 7. So I can plug in a 6 to get y as 1, so forth. But why not? So that's one thing you could do. You could stop here and then rewrite it and then solve. But why not keep going? Because, Jeff, we don't like it yet. Okay. All right, just a couple more steps and I'm done. Right? I can use that one to kill that negative 4. And then I can use that 1. It's going to be a 1 here in a minute when I divide by negative 4. It's going to be a 1, 6. I can use that one to kill that one and that one. Maybe. So, What do I want to do to kill that negative 4 there? Yeah, I want row 2, 4 times row 2, plus row 1, and put the answer where? Row 1. Because I want the 0 to show up here. So this will be 4, 4, 28. Okay. So don't rewrite the whole matrix, just put 4, 4, 28 there. Just put little parentheses. No need for that. So everything else is going to stay the same. So for 2 things, we're going to go ahead and make this one 1, 6. And now this one's going to become 0 plus 1 is 1. 4 minus 4 is 0. 4 plus 1 is 5. 28 plus 7 is 35.
So
when you really get used to this kind of thing, everywhere I'm doing, like right at the beginning here, I used that one to kill that one, and then I did it, and then I used that one to kill that. Well, why not do it all at once? Why redraw the matrix twice as many times as you really need to? So right now we're learning the full-blown how this works. You can certainly make this process a lot quicker by being smart about doing a couple things at once. You know, multiply this guy. So here I would actually write this like this: -2, 8, -2, -14. And underneath here I would put nothing, because I could just add these together. So it'd be one step away from 0, 9, so forth, and 0, 11, so forth. Not 11, what am I talking? -1. I just have to be careful about where I'm looking with these things. So, but I can certainly make this process quicker. There's no way to make this process any quicker than it was, really. It's always set how quick it's going to be. And if I added 1 more row or 2 more rows, it wouldn't really significantly increase the amount of work. I just have to use a 1 to kill a few more things, make a couple more zeros than I just did. Let's see, where am I? Here. So now I can use that 1 to kill that 1 and that 5. So let's try this. So I multiply by -1 to kill that 1. Or I multiply by -5 to kill that 5. Right? So it would be -5 and 5 is 0. -30 and 35 is 5. 0, 1. -1 and 1 is 0. -6 and 7 is 1. And remember what the answer was? 516. Cool.
you multiply by what? The last step?
By -5 to kill that 5. So there's the by -5. And by -1 to kill that 1. So there's the multiply by -1.
Can you stop like first before that?
Yeah, one way to do it is to stop here, like I said, and then translate back into equations. But it's really just a couple more steps to finish the matrix out.
Well, that would be hard if there was a fraction or something. It would be really hard if there was a fraction like in the middle.
I know.
Yeah.
But in R2, isn't it -5 plus 0 in the middle? In R2? Be -5, -5.
No, because 0 times -5 is 0. So I'm multiplying this 1 by -1 or -5 to kill this 5.
Okay.
Cool. So the ones that have more zeros on it, they're like lasers. They pinpoint the thing you want to kill. It's sort of like going in and killing some kind of tumor with lasers. I don't want to kill anything else around it. I just want to kill that one thing. These zeros won't screw with these. That's awesome, because again, you don't want to lose a 0. So you use a 1 here to kill these, use a 1 here to kill these, use a 1 here to kill these. If you do that every time, you'll be golden.
You just put both of them on your matrix. With the top, you put like double team it.
Yeah, exactly, if you want to. That would make this whole process quicker.
Should we show you like what we did or just for them?
Yeah, that last step I could tell pretty much. I mean, that last step was -5 times this and -1 times that. I could see it. So if you're writing this, it kind of helps you too if you keep track of where things came from. Okay. So I might as well go ahead and show you how your calculator works with this. I said I would, so I will. Any of you guys going possibly into computer design, or do you use Photoshop a lot? Anybody ever use Photoshop or no?
What?
Yes, a little bit.
Tell me about it. What are you talking about?
So a lot of times matrices are used, for example, when you want to increase the contrast on a picture. Very often you'll multiply that picture, you'll represent the picture by numbers for each pixel, and you actually multiply by a matrix that will increase the contrast in some areas and so increase the light and decrease the dark. So make the light areas lighter and the dark areas darker. You actually accomplish that by what's called a transformation matrix, right? So I could take an equation and put it into a matrix and multiply it by a transformation matrix. So I could actually have an equation that represents hyperbola. So if I represent that in a matrix, I can multiply that by a transformation matrix that would actually turn that hyperbola by any degree I want it to. So that's kind of a little bit of what you do in linear algebra. You start talking about what does that rotation matrix look like if I want to rotate it by an angle of 30 degrees? Because that's really freaky. Right? Chapter 11, we're going to get into these what's called conic sections. But if you guys know about hyperbolas a little bit. So if I want to take a hyperbola, they're normally like this or they're like this, right, on the x or the y axis. Well, I want to rotate it like that. I should be able to. And actually, one of the easiest ways to do that is to use matrices, what's called a rotation matrix. So, does anybody listen to Pandora? Yeah?
Spotify.
I love my Pandora, right? It's a bunch of researchers who love music. So it's free. You gotta go through some ads, but it's really nice. The ads aren't that bad because they're just trying to collect data. That's what they want. So I love it. They just want data. So they want more and more and more people to use it. What they do is they take, have we talked about it yet in here?
No.
They take a set of characteristics of a song, right? So they have like jazz, I think, has the most characteristics that you can describe, and they actually create this giant matrix of all these characteristics. And they use linear algebra. You can actually determine how far apart two matrices are. So they have your matrix of what you like, and this other song that they want to try to play, and they first see how far away is that from what they said they liked. And if it's not very far away, they'll play it. If you say you like it, then they say, oh, our algorithm is working really well. It's just more data for them to chunk in. If you say you don't like it, they go, oh, what happened? Why was that bad? They try to identify what it was.
That's Pandora?
That's Pandora. It kicks so much ass.
Because you don't like it for reasons?
What's that?
What if you just don't like it because
I know. So they all, just like any statistical analysis, you have to feed into their personal biases. So if there's a certain person, I would like their songs if I didn't hate them for some reason. Like they stormed on stage when somebody else was saying something or something. I don't know, it didn't bother me, but just in case it did, something like that, that would be an anomaly. There wouldn't be any other things that would back it up. So eventually it would get forced out of their algorithm. You kind of with me? But if you do something and you do it again and they kind of see a pattern, they're like, oh, now we understand better what this person likes. And then it just gets better and better. So recently I've been loving every damn thing it's throwing at me. Like, I never heard that before. Shit, who's this person? You know, and so it's awesome. And the early going is kind of like, no, okay. You know, but it's just getting to know you. So that's an application of linear algebra, which is a class devoted to applications of matrices. What's that?
I said I never thought about to come down and use that stuff in my house.
Oh, really? Even if you hate it?
I'm too far away from it. Yeah, no way.
I like that, man.
On the computer. you can go
Starts
down
playing
and-
country, you got to tell it. No.
I thought, yeah.
Sorry. Sorry for that telling country. All right, so now I would hope it's pretty obvious where you might want to go. There's a little matrix button right above the x to the negative 1. So everybody, if you got your calculators, there's one left up here. I think I have a couple left in my bag if you need one. Second matrix just to get into this. Now, this first screen is really just to do math to it. So if I wanted to do math to a matrix, I would go pick a math operation and then pick a matrix. So right now, I want to edit a matrix. I want to actually create a matrix. Does anybody have stuff here?
Yeah.
All right. So if you've if your calculator's been used before, you might have like 1 by 2 and 3 by 4 or something like that.
Yeah, 3 by
With me? Okay. So let's all do A. Even if it's got stuff in it, we're going to overwrite it. So everybody pick A. So mine starts off as 1 by 1. It's one poor little number by itself. We actually want it to be, and I know I called this a 3 by 3, but I was saying it's definitely how many rows by how many columns. It's 3 by 4 if you look at all the numbers. So I want to say this is a 3 by 4. Cool. Okay. And then you just start filling it up. And of course, I can't see a damn thing because of glare. So starting off in the very beginning, I think this is the beginning here, right? Yeah. So 1, -4, 1, 7. What I get for trying to do this quick. -4. 7.
2,
1,
1,
-2, 1, -1. Thanks, guys.
-1,
3, -2, -14. -2, and then -14.
Okay, cool. So now we got the matrix in there, and the unfortunate thing is you can't see the whole thing at once. They leave room to round decimals in case it comes out to decimals or whatever. So now what we want to do, right now we actually want to hit second matrix, come back in there. And what math do I want to do? None of this stuff, we don't know what some of this stuff means. But let's do both. Reduced echelon form is like the early stop, when you have the upper triangle still with numbers in it. You haven't made all the zeros that you could. So that's going to be REF. Hopefully it's here, so there it is. REF would be stopping early. So let's try the REF first. Please don't tell me, I knew it. That's the step I always forget. Second quit to get out of there. So if you're still in your matrix, you don't want to put an entire matrix inside your matrix, because then it sounds like some weird Keanu Reeves Inception movie. Put the matrix inside the matrix. So you want to quit out of your matrix first. That's my fault. Go back to matrix here and go to math and REF. All right, now we're back on the home screen. It's not going to try to put an entire matrix in there. And I want to row echelon form. I want to row echelon form that matrix A. So you go to names, and that's how I pick one single matrix A. So when you hit enter, it's going to actually put the answer here, and it tells me strange things. Oh yeah, that's right. Why is this fine? Where was ours? Is this fine? I don't think so. Oh yeah, it might be actually. Yeah, of course. This is fine because. Say again.
How do you put A in there?
Oh, let me do it again. Go to matrix. Go to math. A. And then go to matrix names. Pick matrix A. All right. What's up? Did I do it too fast? So go to matrix, math. A is the REF. Go to REF. And then you got to go to matrix and tell it which matrix you want to use. I want to use matrix A. Okay. So the reason this is, remember on this step here, here. See there's a 3 there? And we switched those two? You vaguely remember that? So they didn't switch that one. So of course if you divide by 3 to make a 1 show up here, won't you get a -1/3, which is -0.333333? Right? Cool. So that's why that doesn't look the same. But if I go to RREF, no matter what way you did it, it has to look exactly the same because there's that one single answer for this. Let's try to go to RREF. So go back to matrix, math, RREF, and then matrix This gets a little annoying. Row reduced echelon form A, that's going to be going all the way down. So there's my 516. Shake.
Mine gave me 1, 0, 0.
Oh yeah.
Does it work? What is it? Oh. Because it's actually you've got two different matrices. And what you're doing actually is multiplying these two. So I think you don't have to that line I just put it in there for me. So in the matrix you actually can just add another column. I think these are two separate matrices. So it actually was doing that multiplication.
Alright, so is that alright? So you can imagine, I mean, again, for any computer programmers out there, if you wrote a computer program that would do this for a matrix, computers of course don't care about fractions, decimals. I don't care how large the matrix gets, it would just be a loop until it's done. So no matter how big this matrix gets, it would just be a few more seconds for it to finish it out. So writing it in matrix form makes it into an algorithm that's really easy to repeat. It's a very single-minded thing. When I was taught this, we were taught not to move a damn thing. We'd have to divide by 3, deal with the fractions. You make a 1 no matter what. Which is really kind of stupid, to tell you honestly. I would never make a fraction in here at all. Even though I should be okay with fractions, why would I give myself one more place to screw up? So if this was a 2 and this was a 3, I would just multiply this row by 2, this row by -3, so I'll make a 0. The most important thing is making zeros. I can always make a 1 at the end. I just divide by whatever, and then I get fractions at the end. Who cares about getting a fraction at the end? I don't want to get fractions in the middle. That sucks. Are you guys semi with me? A little bit. And to tell you honestly, if this was a 3 and this was a 2, I would just subtract them directly. And then I get a 1 there. That's an even better way to do that. You force your 1 to be there, right? Maybe. So the nice thing is you've got this back up to check your work.
So can we use the calculator to test?
What's that?
Can we use it to the test?
Oh, hell yeah. To check your work.
But if we do it like one step, we are smart. When we do it.
Well, that's nice.
Yeah, that's
How how smart you are. You got to show me something. That's what I told one of my 88 students. I can just see it. Yeah, you can just see it.
like you can do two steps.
Your calculator can see it. I'm not trying to say anything against your intelligence, but this kind of problem, I doubt if you just look at that. I don't have any Rain Man in here, right? It's definitely 247 toothpicks. I don't have any of that going on that I know of. So you got to show me something. Okay. So how do you guys feel about that? I mean, if I made a 5 by 5 matrix, by hand it wouldn't add that much work on. It'd just be one more 0 to make in each column. It's not really that much more work. Yeah.
On the test, are we gonna have to write this out?
Oh yeah. So obviously, I'm not going to give you like a humongous problem. I'm not going to give you 8 of these problems because they are time consuming. So I'm completely aware of that. So I'll probably give you one problem this big that you must show me the steps, and that would be plenty. Right? Anything more would be busy work.
What if we showed the steps, but our answer didn't come out to people who got the calculator?
Then just say that. If you can't see where it went wrong, it's either you're entering in the calculator incorrectly or something went wrong here. Yeah. Yeah.
Does the book stop at RAF or does it keep going? Like,
No, the book keeps going.
all the way through?
I think they do. Yeah, they do. They have Gaussian elimination, and then they have what should be called Gauss-Jordan elimination. There it is. Space 654 Gauss. So this is Gaussian elimination is to go to here, and this is what's called Gauss-Jordan elimination to go to here. So this took a little collaboration between two people called Gauss.
We use it both, right? Like, we can stop there. And do that.
Yeah, I think the homework asked you some did stop and some not. So just to let you know, but if you can go here, you certainly can go there.
Yeah.
And stop, yeah. Okay. Oh. So let me show you a little preview of what's coming up.
No.
So I had to throw out, if you guys have noticed, I had to throw out several sections in 10. One of them I didn't throw out is 10.4. That's where we're going to get into how to multiply matrices. And it's not anywhere near intuitive. It's not difficult. It's just not what you think it would be. All right, so how many of you guys have multiplied matrices before? All right, several of you. Good. Okay.
Was this 10.3?
This was 10.3, yeah. So 10.4 is going to be that. And at the end of 10.4, it gets a little bit into manipulation of photos for like Photoshop or something, and how matrices can be used for that. But I mean, that's just barely scratching the surface. I mean, you could devote your life to studying the applications of matrices and using them. I don't want to do that, but they are useful. The ones I had to throw out are really, it's unfortunate that I had to throw them out, but these are the lesser ones that we really need to know. It's solving equations like that where these are both matrices. So you actually get into, there is no matrix division, but there are matrices that when you multiply them, you get the identity. You get like 1, the equivalent of 1. So you would multiply both sides by the inverse matrix, and those would cancel. So the whole thing about that section that I threw out is how to find that inverse matrix, and then go ahead and solve an equation. So it's the same idea. I have to know the inverse of something to be able to solve an equation if something's sitting in there, right? If I have a matrix sitting in my equation, I have to know the inverse matrix in order to solve it.
Do you need that in calculus?
There are a couple places in calc where matrices come up, but you don't do anything too directly like this. This is more straight up linear algebra. Yeah. And I know you guys really don't want to hear this because I threw these out, but still, 10.6 is something that some Math 110 teachers teach. Depending on your teacher from Math 110, if they did any matrices, they could do something called Kramer's rule. Anybody ever heard of Kramer's rule? Remember it? Not Kramer versus Kramer. Kramer's rule. Yeah. The one that I definitely had to keep though was section 10.7, and 10.7 is going to be how do I go from this into that, because that could have come from the addition of those two fractions. You with me? So that's what's called partial fractions. Stupid useful in calculus. If you're not going to go to calculus, you got to know what to pass the test with this one. Always a motivation. And the last 2 in 10 that I had to throw out were, and this is too bad, but systems of nonlinear equations. We did systems of equations today. But what about systems of nonlinear equations, stuff like this? It's really the same thing, truly, to tell you honestly, but that's not a very good example of one. That's an easy one. It's not linear, but I can still do elimination, right? The more interesting ones would be like xy equals 7 and x squared plus y equals 2. Try to figure out what to do with that. Yeah. So you can just, I guess, be thankful we're not going to do that. And then we will get in chapter 11 next time. So next time I'll finish out what we got to do in chapter 10. We will get a little bit to chapter 11. That's going to be the parabolas and the ellipses and the hyperbolas. Oh yeah. We're not going to be rotating them, so don't worry about it.
So the quiz on chapter 18, right?
Quiz on chapter 8 is this Wednesday.
What's the most important things we're going to need to know for TD?
Chapter 8.
Yeah, for chapter 10. I mean,
That's my answer.
No, the whole thing. Are all the corrections due on next test or this quiz?
Corrections always due the day of the next test.
I don't know, but yeah, if you threw out the test.
No, the next test is still test 4. And then the next test after that is the final. So it's always the day of the next test. Yeah. All right, guys.